Alright, welcome. So my name is Nick Macias. I'm from Cell Matrix Corporation, and in this video I want to talk to you about the exist system, and I want to go through the API for interacting with the system, running simulations, and getting a feel for what the system looks like as it runs. So let me start with some sample code. So I'm sitting in the sample code directory. You can find all this code on GitLab. And I want to look at a set of code called Go7 and Main7. So Main7 looks like this, and this is pretty much boilerplate. You're going to use this code almost verbatim for all these experiments. The only thing that changes is the name of the class that we're constructing and then calling the start method on. So Main7 goes with Go7, and whatever you call your file, obviously the class has to be defined with the same name as the file name itself. So here's Main7, and all it does is construct a Go7 object and then call the start method. The rest of this code you can leave pretty much unchanged. So let's look at the Go7 code, and it's a pretty short program, 34 lines. Import the API code as usual. Set up the Go7 class. It's got to extend a thread, and I'm creating two objects, an exist object and a display object. The display will display information about the system as it runs. And then you need to put all your code inside a public void run. That's what's executed when you call the start method. So first thing I do is construct an exist object, so just new exist, and I call that E. And then I create a new display object, and I connect it to that exist system by passing that to the constructor. And I make the display visible by calling set visible. Run num I'm just using to keep track of how many runs I've gone through. And then this is my main simulation loop that loops forever. So that's the whole totality of the program. So bump up the run number, clear the tubes in the exist system. That's just the clear all tubes method. And then I set a range of values from 10 to 20, incremented by the size of our spatial delta increment dx. And for each of those tubes between 10 and 20, I pick a random number. That's going to be the amount of source and destination chemicals. So it's something from 0 to 40. And I call set tube to set the amount of source and destination equal to that random number. What this will do is fill the tubes between 10 and 20, each tube with a fixed amount of source and destination equal to each other, but that amount can change from tube to tube. And then I step the simulation 22,000 times with 4 steps in between each, so a total of 90,000 simulation steps. And every 25 times 4, every 100 steps, I just print out the run number and the step number. And that's all this code does. It'll do that, and it will loop forever until I exit the code. So there's a pair of compile and execute scripts in here. The compile code just calls Java with a class path of your current directory and wherever the API is located. For me, it's located one level up from my sample code directory. And I just use the argument name.java, and the run command just uses Java with the same class path. Note that on Linux you need to use a colon instead of the semicolon. On Windows, semicolon seems to work. So I'll compile main7, I'll compile go7, and then I'll run go7, and sorry, I'll run main7. And here's our code executing, and you can see the step numbers coming out down here. This is our basic display, and I can zoom into this or blow this up, and it doesn't look like a lot is happening. If I click anywhere in here, I get this live display that I can expand the window, and with the scroll wheel I can zoom in. With the shift scroll I can zoom in the other dimension, and we can see that nothing is changing. Each tube has a different amount of source and destination from its neighbor, but within each tube the source and destination concentrations are the same. So these are basically NoOps. Each tube is saying transfer from tube Q to tube Q, and that's a NoOp. It doesn't actually cause anything to move anywhere. And so even though we have an interesting distribution of chemicals, the system is completely stable. Now let's play with that a little bit by making some changes to our code. So let me go back into Go7. And let me come down here and set the destination to be slightly less than the source. So each tube is now going to say transfer from some random tube B to the tube 0.02 positions to the left of it. And let's compile that and run it. And now if I look at this system, we see that we have a certain amount of chemicals, but they're slowly shifting to the left. So let me zoom into this. and you can see what's happening. We have some sort of small shape change taking place, and chemicals tend to be drifting to the left. And this will run for the full 90,000 execution steps. And that's kind of interesting, perhaps. So let's go ahead and change the code again, and let's increase that increment from 0.02 to 0.2. And now when I look at this, we see that it's moving much more quickly. And as it hits the left edge, that tube begins to saturate. And the system will eventually stabilize in something with all the chemicals on the left, but the system isn't conservative yet. So the things that are going into tubes with negative destinations, those chemicals are simply being lost. So we can see all kinds of experiments that we might want to do. We might want to see what happens if we move this tube over. For example, start from 30 and go to 40. And let's go back to a 0.02. And here again, we see some sort of shift to the left, but the chemicals over on the right side of the system seem to be staying more or less intact. There's sort of a spreading out of this effect now instead of a simple migration from right to left. And that's potentially interesting. We can look at it over here and see a little better what's going on. So this is showing us a time trace where time runs from the top to the bottom, and spatial coordinates are shown in the usual horizontal axis. And you can see this spreading out that's taking place, where these chemicals on the right are staying in place, but more chemicals are moving to the left. Alright, well that makes you think that, hey, maybe there's some interesting things we could learn by changing these numbers, but we keep going into the code and changing them. In the next video, let's hook up a control panel so we don't have to keep changing the code and recompiling. We can actually change things while the system is running. So that'll be our next video.